Okay, we are doing section 7.1, and it's about, this whole chapter is about not congruent triangles. We're going to talk about different figures. We'll end up talking a lot about triangles. It's not all about triangles, but a lot of it is about triangles. And we're going to talk not about congruent figures, but things that are similar. And we'll talk about that quite a bit. But before we do that, let's talk about this, ratios. See how nice it looks in blue? Isn't that pretty? All right. What is a ratio? If you just like a regular everyday word, a ratio would be. Give me something. What comes to mind? A what? A number out of something. Good. A what? A comparison. That's good. Okay. Something that we probably use a lot in math. If I was going to set up a ratio, I could say something compared to something else, or something out of something else. How do we write that as a math problem? A number over a number. So what is that? What's anything over something else? That's a fraction. That's right. So ratios are basically fractions. Okay. So if we talk about a ratio, we talk about fractions. Here's a word that you'll see a lot. You'll see, and we might have talked about this already. I'm not really sure, but especially in algebra, you'll talk about things, rational expressions. So if you see the word rational, you might have seen that word before, but I remember when I was growing up, my teacher would say rational. He'd say all kinds of words, and I never really knew what he was talking about. They said it all the time. I had no idea what he was talking about. But look, if I say a rational expression or something that is rational, what word that we've talked about is in this word rational? Ratio, okay? And basically, a rational expression would be what kind of an expression? It'd be what? It'd be a fraction, wouldn't it? Yeah, it'd be a ratio. It'd be a fraction, okay? So if I'm dealing with fractions, I'm dealing with rationals. Everybody got that? Okay, so I just thought that's kind of important to do. All right, so let's do this. So if we talk about a ratio, Nico said something out of something. So for instance, we have like, I don't know, 26, 7 people in here, something like that. I'm just making these numbers up because I'm not going to take the time to count up. But let's say we had like 10 boys and we had, what would that be, 17 girls? Whoops, IRLS, okay? So what if I wanted to make the ratio of boys to girls in here? If I wanted to write a ratio of boys to girls, how would I write it? It's pretty easy. 10 to 17. Okay. What if I wanted to make a ratio of girls to boys? Girls to boys. That would be what? 17 to 10. I'll tell you what. Let's do this. Let's say we do have one person absent today. So we have 26 anyway. All right. So let's just say we have everybody. I don't really care if these numbers are right or not. Let's go 16 just because I want to do something with this that I wasn't thinking about. All right. So let's say we had 16 girls and 10 boys. Okay. So we have 10 to 16 would be the boys to girls. 16 to 10 would be the girls to boys. What if I went the boys to the total in the class? We'll put total. What would I go? 10 to what? To 26. Good. Okay, what if I went girls to total in the class? All right, and that would be 16 to 26. But in math classes, what do they always harp on you to do? Reduce the fractions. So if I went boys to girls, right, show your work, but in fractions to reduce.
For every 5 boys, you had like 8 girls.
Right, exactly. Okay, so watch, if I reduce this, let's see, 2 goes into both of those, it'd be 5 over 8, right? Now, if I said, okay, the ratio of boys to girls is 5 to 8 in this class, does that necessarily mean in this class there's only 5 boys and there's only 8 girls? No, it doesn't mean that. It means what? For every 5 boys, there are 8 girls. Does that make sense? Okay. That's why I wanted to simplify, because I wanted to get a fraction that didn't necessarily, mean that's exactly how many boys and girls in the class. It's a ratio. It's something that is a comparison. For every number of these, you have this number of girls, okay? Same thing with this. So this would be 8 to 5. And again, that doesn't mean there's only 8 girls in the class and 5 boys in the class. It means for every 8 girls, there's 5 boys. Okay, and then you do the total. Then what would that be? That would be, what, 5 over 13? Is that right? Okay. Again, that doesn't mean there's only 13 people in the class. But it means for every 5, let's say, for each group of 13 people we have in here, how many in that group of 13 will be boys? 5 will be boys. Does that make sense? So we could have like hundreds and hundreds of people, but if our ratio stayed the same, right, for every group of 13, then there's, of boys and girls, 5 of them are going to be boys. Make sense? Okay, so that's just basically what a ratio is. We use ratios all the time. They give an example in the book about batting average. Okay, how do you find the batting average in baseball? Batting average. How do you figure that out? Yes, the number of hits you get to the number of, we'll call it at-bats. Okay, how many times you come to the plate. That doesn't count walks, remember, because walks don't count against your batting average, but we'll just forget about that. But if this number of hits over the number of bats. So let's say somebody bats, we'll just make it real easy, 100 times, okay? And let's say they get 35 hits. All right, so what's our batting average then? 35 over 100, which would be what? 0.35. But in baseball talk, we don't say 30, they don't bat 35%. I guess you could say that if you wanted to, couldn't you? How many times do they get a hit? Well, 35% of the time, or 35 out of 100 times they get a hit. Now, we don't say that, and we don't say 0.35. What do we say in baseball talk? We say they're batting what? 350, okay? That's really a decimal. Did you realize that? It's 0.350, so they're batting 350s. 350 a good batting average for baseball fans? Yes, it's a very good batting average. Okay, you'd probably be MVP of the league if you hit 350 the whole entire year. Okay, it's amazing about baseball. I mean, 35%. That's roughly what, one in 3. So you can go up, fail twice as many times as you succeed, and you're the best in the league. Isn't that crazy? All right. So what other sport could that ever happen? I don't know. But that's just, yeah. And that's right. I didn't make that up, by the way. Okay, I had heard that. Ted Williams said that. Is that where it came from? Good. I didn't know that. All right, watch, another cool thing I can do. I can scooch this up like that. Isn't that cool?
Oh, yeah, that's cool.
All right, exciting. I can't see in the dark without my glasses on. We could do this, too. I'm not going to do a whole lot of this, but we could, well, actually I will. We could compare not just 2 things together, but maybe 3 things. Maybe we're comparing 3 classes or something like that, or maybe colors. I've got 3 colors or something like that. We can do comparisons to that as well. A lot of times when we do comparisons or ratios, we don't just go, one number over another. What's another way we can write a ratio? You've probably seen this before. Probably middle school, you did a lot of this stuff. Chandler?
The like 2 then the time thing. The 2 dots. Or
The 2 dot, the time thing. I know what you mean. The colon. It's not a semicolon. It's a colon, right? So, so if I use A and B, what would it be? It would be A colon B. So if I talk about comparisons, I'll put this in quotes. If I say it, I would say A T-O-T, right, to B. That's how I would say it. I'd say both of these things the same exact way. Does that make sense? So the first one right here is the one that's going to go on top. So I'm comparing A to B. I could compare 3 things or 4 things or 5 things if I wanted to. Okay, I could go A to B to C. Now if we start comparing 3 or 4 or 5 things, we get away from the fraction. We just stick with the fraction if we're only comparing 2 things to each other. But if we do 3 things, we usually use the colon, and that's how we say it. A to B to C. Everybody got that? Pretty easy. You've probably seen stuff like that before, haven't you, in other math classes? Probably. All right, let's do one that deals with geometry. It's on the top of page 458 if you want to look at it. It says the ratio of the measures of a triangle. Let's write it down. The ratios of the measures of a triangle ABC is 3 to 4 to 5. 3 to 4 to 5. Now look, does that mean that inside this triangle, let's just draw a triangle. Again, I don't even care if it's to scale or not. We'll just do it like this. All right, there's a triangle. In this triangle right here, does that mean that this angle is 3 degrees, this angle is 4 degrees, and this angle is 5 degrees? No, of course not, because what has to be true about all these angles? They have to add up to 180, don't they? Okay, what it's talking about is talking about the ratio of the angles, right? So what it's saying is 3 times a certain number is this angle. 4 times that same number is this angle. and this one is 5 times that same number is this angle right here. So how do you think we're going to work this out algebraically?
So like the ratio, they all have to be 1 apart from each other. Like 1.
Now, not necessarily one number, but that means for every 3 here, there's 4 here, and there's 5 here. For every 3, there's 4, there's 5. So this, what it means is 3 times a certain number. This is 4 times that same number, and this is 5 times that same number. If you add all those up, you'll get 180 degrees. So what are we going to call that same number? X. Okay? Follow me? Because that's the same number. This would be 4 what? X. This will be 5x. Right? So this right here is what we're trying to work with. It's 3 times a number, 4 times the same number, 5 times the same number. If I add all those up, I should get what? 180. So let's set up our math. Instead of 3 plus 4 plus 5, what are we doing? We're going 3 what? X plus 4x plus 5x equals what? 180. So what we're going to do is we're going to solve for x. Once we solve for x, then guess what we're going to do? Plug it back in, exactly. All right, so let's do that. That's 7 and 5 is what? 12? I should be able to do this in my head, but what's 180 divided by 12?
16.
15, I think, isn't it? Yep. That was my guess. But
That's close.
okay, so x is 15. Is that my answer? No, what they're asking for, I didn't even tell you what they're asking for. They're asking you to find each angle, okay? So we're trying to find each angle. Now, you have to know x is 15 to find all these angles, but let's plug it in and see what we get. So 3 times, let's just do this in our head. 3 times 15 is what? 45. So that angle is 45 degrees. 4 times 15 is, what, 60 degrees. Okay, 5 times 15 is 75, I believe. Somebody do that for me. Did they add up to 180? 45, 75, 60? Yep, they do. All right. What's that? Do they? Okay. I thought you said they don't. Yeah, they do. And it's 180 degrees. And there you go. You found each one of these angles. Now, again, watch. The ratio is 3 to 4 to 5. What was the actual angles? It was 45 to what? To 60 to what? 75. Now, what do all 3 of these have in common? They all have a 15 in common, don't they? So if I divide out of 15, what am I left with? 3, 4, 5. Do you see it? So what I had to do is I had to find what was in common with all 3 of those angles. And I did that first, didn't I? That's why I put the x here. Everybody understand that? Okay, that's why I put the x right here. And that makes it pretty nice. When do we get out of this class? 10:31. Oh, I got a lot of time. Okay, so I'm sure you're thrilled about that. We don't have that much more to do. All right, everybody good with that?
Oh, yeah.
Okay. All right, let's move on. And let's change colors.
Wait, 31?
Let's get through this.
I thought it was 25.
Make it a pretty color.
20.
This is Wednesday's schedule, right? 10:31 I'm looking at.
Do you have any, like, purples?
No,
It's 31. Purple? Yeah, I think there's some purple down here.
Purple.
Let's do purple.
Raspberry.
Raspberry? Okay, we'll do raspberry. All right. All right, let's do another one. You've seen this before. They call this the cross products. You can't see that very well? Let's try another purple.
Sunshine, sunshine, sunshine.
How about magenta? Yeah, let's go magenta. Cross. That's not much better.
Can't see.
How can you not see that?
Are you kidding me? Oh, yes, you can. I can see it.
Up front.
I can see it
Can
fine.
you sit up front?
You want to sit up? Yes, I thought. Wow, it's a miracle. All right, so cross product, what do they call it? Property. Now that's a lot of words to say something that you probably know this is something else. Watch this. If I had A over B equals C over D, all right? Right here. By the way, before we even talk about this, when I have 2 ratios set equal to each other, and do I have that situation right here? Yeah, absolutely. We call this thing a proportion. Proportion. Okay? So for instance, listen to this. What if in this class we had, what did we say, 10 to, what was it, 16? Okay, that was what, boys to girls? Okay. So what if we had this in this class, but next door they have a smaller class, but they have 5 boys and 8 girls. Let's just pretend, okay? Probably not true, but let's say they have 5 boys and 8 girls. What's true about our proportions? They're equal to each other, aren't they? All right. So both classes, even though I have a lot more people, actually twice as many people as they have over there, their proportion is still the same. How can you check if it's the same? Well, you could always just reduce this thing, or you could do something else. This is what they call the cross product property. You probably know it by something else. Cross multiply, that's right, okay? So watch, multiply across like this, multiply across like this. 10 times 8 is what? 80, and 16 times 5 is 80. So if I multiply diagonally like this, and if they're exactly the same, it means those fractions are equal to each other. So it means that's in proportion. So we say something is in proportion when one fraction is equal to another fraction. Everybody got that? So anytime you have a fraction and reduce it, if they're equal to each other, those fractions are in proportion. So what they're going to do is, I do need a little night light here. When the lights go down, I can't see very well. I got to take my glasses off. Most people have to put glasses on, and then I got to get real close. By the way, sometimes they call this the product of the means and the extremes. I think they call one of these the mean. I think they call these ones right here the extremes and these the means. So if you ever hear that, I will rarely ever refer to it like that. But you might hear somebody say, oh, it's the products of the means and the extremes. And you're like, what are you talking about? They're just talking about cross multiply. That's all they're talking about. Okay? Say what? No, that's okay. I've got one actually. So, all right. Okay, good. Thanks for your concern, though. All right, so watch this. If I was to multiply these together, what would it be? It would be what? AD equals what? BC. All right, and you can do a lot of work with this. Let me find a good example. What if we had this? What if I had 4 over 10 equals 6 over x? Okay, what if I had something like this, and I wanted you to... They're proportional, right? Because the fractions are equal to each other. And I want to find out what x is equal to. It's not quite as easy as saying, well, 4 times what is 6? Well, 4 times, I don't know, not 2, because it's 8. It doesn't come out nice and even. Sometimes they don't come out real pretty like this, and we got to figure out what this number is going to be. So what do? We cross multiply. And that's how I'll refer to it. I probably will never say the cross product property or the product of the means and the extremes. I'll probably just say what? Cross multiply. And that's good for you because that's what you're used to hearing anyway, isn't it? Okay, good. So we cross multiply. So we multiply diagonally. Now look, the only time you cross multiply is when you have a fraction equal to another fraction. I've seen this before. I've seen people go 2/3 times, I don't know, 5/7. And they go, oh, cross multiply. Is that cross multiply? No, that's just regular old multiply, okay? Regular multiply, you multiply across the top and you multiply across the bottom. Okay, this is not where you apply cross multiplication. Where do you apply it? You apply it when you have a fraction set equal to another fraction. Everybody with me on that? Okay, so what do we get here? We get 4x equals what? 60. And then divide by 4 and you get what? That's 15 again, isn't it? Okay? And that's how you would solve for a missing number. That worked out pretty nice and easy. Sometimes you'll get crazy fractions right here. Sometimes they'll compare fractions to each other. And it's not as easy as just looking at it and telling what it should be. So you have to learn how to cross multiply. Not that big of a deal. Let's do another one. That was a pretty easy one. Let's do one a little bit more algebraic. So x plus 3 over 2 equals 4x over 5. And I want to solve for x right here. Now, something like that, I don't know, you may be able to just plug a bunch of numbers in and see which one makes the fractions equal to each other, but it's probably not the most efficient way to do it. So let's cross multiply. Now, if we multiply diagonally like this, you got to be careful though, because that 5 is not just being multiplied by x, it's not just being multiplied by 3, it's being multiplied by what? The whole thing. That's right, so you distribute exactly. Okay, so we can just, I don't know, let's just write it out. I'm not gonna assume you can do that in your head. You should be able to, but we'll write it down. And then you multiply that together, right? 2 times 4x, we can figure out. I'll tell you what, I'll just do this, just to show you all the steps. Okay? And now let's finish this up. What do we get? 5x plus 15 equals what? Just 8x. Subtract 5x from both sides, you get 3x equals 15. Divide by 3, and x is 5. And there you go. All right? You with me on that? It's not too hard, is it? I don't think so. Let's see what else we have. Oh my goodness, are you kidding me? That's about it.
Oh man, yes. Good job. We learned a lot.
We did learn a lot today.
Oh man.
Let me just see. Yeah, I think we're fine. So let me give you some problems to do. I know you don't want to be left out. It's been a while since you've done some math homework, isn't it?
Yes.
Thank you. Now I can see.
Do we have nothing Friday?
Yes, we do actually.
First period.
So it's pages 460, 461, and we're doing 12 to 30. Okay, and that's section 7.1. How about all of them? It's not much. Okay, so there you go. You're going 12 to 30 at section 7.1, and that's due tomorrow. Enjoy.